In this video we're going to go over the code that's available in SparkCore. SparkCore contains several things. It contains some rules files, it contains some generated Swig files, generated header files, and then some several services that should make your life easier. So first we're going to look at the rules files. We've got rules files for enum header generation and generated Swig bindings. These can be added to your own project by simply adding in some lines to your VCProj. So these lines right here added to your VCProj file will give you the rules files we use, assuming that you set the relative path correctly. And that will give you the ability to automatically generate header files from .enum files, which will allow you to map IDs much easier. So this is an enum file, and you see basic XML. You can copy and paste and change these, and it's very easy. But that lets you then reference the core message IDs using this header file and this variable, this static variable, which is easier than having to paste this number in a bunch of spots, and it allows the numbers to change and you can recompile and it works still. It also the rules files also allow the Swig file generation. So we use Lua as our scripting language, but you could use Python or anything else, and Swig has lots of languages it can generate for, so switching to a different language should be fairly easy. This .i file tells Swig what to parse and which files to open, and then from this is generated something like Spark Camera Lua. Now if you don't have the Spark Camera Lua, it's because you haven't built yet, so just click over there and hit build, and it should show up. Again, it's a generated file, so if you haven't built it, you don't have it. And you shouldn't really edit these files. They even say don't edit on the top, but this will allow you to interface with your camera from Lua. So very useful. So what other than these generated files and the ease of use here, what does SparkCore have? Well, it's got shared functionality that should be useful in many applications. It's used itself by both multiplayer game and alpha game, and then the racing game, which is a subset of alpha game, uses this as well. In it, we've got some more bindings that are these are the CPP files and H files that Swig parses to bind Lua to C++. We've got some built-in models, which are different cameras and weapons and attachment stuff that's used by both multiplayer game and sometimes by alpha game. A game state system, which will handle your splash screen and your loading screens and transitions. And that's extended by alpha game in one direction and multiplayer game in another. Multiplayer game gives you lobbies and different network-based stuff, and alpha game just loads you right in. It has initializers, which will help you initialize large numbers of services easier. Prevents that giant chunk of service initialization that you see in most of your Lightspeed-based samples. Got some post-processing effects, and we have a bunch of services. Again, these handle HUD, game state, some physics helper. There's NX character controller, which is the animated character solution by PhysX for in a physics world. There's some occlusion stuff, cameras, game state. That's about it for now, but more's coming. Oh, and screen text stuff. So, having done the run through of this of EGM SparkCore, and again, this builds to a library called EGM SparkCore.lib. There's no DLL configuration right now, but one could be created. So if we see in the SDK folder, Win32 lib EGM SparkCore.lib. That's what we're building. But there should be a copy of that when you pull down from SVN, so you don't need to build it unless you want to. Then when we go to alpha game just manipulates, uses the SparkCore services and has a small extension to the loading service in order to run itself. So if we look at main service here, inherits from EGM Spark main service, and what it does is it uses Spark to initialize itself. So there's a nice place where you can add your static built-in init functions here, and then in setup services it uses that Spark setup services that was mentioned previously in the service init map to tell to initialize services, to tell Spark what to initialize. So here we've got like initialize core services, initialize physics services. You can set it to not initialize rapid iteration by using the service init map, and that gets passed to initialize core services and initialize physics services. There's also the ability to use WIs, and at some point there'll be the ability to use scaleform or not use scaleform. So this really cuts down the size of this function. I know in some other Lightspeed samples it's huge. Also makes it easier to understand. Spark at this point in time initializes Spark physics initializes all of PhysX, so not just rigid, not just collision, but also full rigid body support and ragdoll and everything. So you might need to alter that depending on what you're using, but you shouldn't need to add anything to it. You'll just be taking stuff away. The last thing to note here is the loading state services, or the game state services, all transition based on string names, so make sure your string names are correct as you're using it. And that's it for this round of the Spark Alpha Game Ignite overview. The next round will go into what's required to have a level loaded by the Alpha Game executable.